Okay, so that's projectile motion. That's a motion. That's a motion diagram for. It's a motion diagram example. Okay, so just another question I'm going to ask, just a simple question, and we're going to be segueing into the next topic. This is the last thing we'll be talking about this video. So the last thing, before we do that, let's just introduce this. Let's have another motion diagram question. So we have another motion diagram question. So this is going to be a pretty simple question. I'll just draw a car really quickly. Let me just select that really quick. Okay, so let's look at two different roads. Okay, let's look at two different cars. So we're gonna have two different roads. So this is one of the roads. This is gonna be another road. All right. So let's say this is gonna be the motion of car A, and this is the motion of car B. All right. So let's say car A and car B both start at the beginning, right? So this is how car A's motion is gonna go. This is a simple motion diagram. That's car A's motion when it gets to the end. This is car B's motion. Okay. My question to you is car A or car B traveling faster? Okay? Pause the video, see if you can figure that out, and when you can figure it out, come back. Okay, so if you understood what motion diagrams is, this is kind of simple, right? So if we look at the distance, remember, each of these frames is an equal amount of time apart. So remember, this is frame 1, this is frame 2, this is frame number 3, this is frame number 4. Likewise, this is frame number 1, frame number 2, frame number 3, frame number 4, frame number 5, and frame number 6. So if it kind of tripped you up how there's more cars here than cars here, or frames in the motion diagram, that's because within this fixed distance from this side of the road to this side of the road, and this side of the road likewise to this side of the road, we were able to fit in more of the car B's than more of the car A's. That's why we were able to generate more frames. And just by looking at it, you can see that as each interval of time passes, the distance between the frame 1 and frame 2 is this length, the length of this arrow. That's for car A. But for car B, it's pretty small, the distance between each frame. So because in the same amount of time, car A travels a greater distance from frame 1 to frame 2 than it does for car B from frame 1 to frame 2, we can say that car A is the faster one. Okay, so car A is the faster one. So that was the solution, but I want to go a little bit deeper, okay? Let's go a little bit deeper. Let's talk about something called the particle model. So I'm going to tell you what that is, particle model. Okay, so a particle model, let's draw the exact same scenario kind of, where a road is there. Okay, so in physics, we primarily like we in this video, what we've been doing before is we've been looking at the object as a whole. So we've been treating this as a car with a mass and a shape and a size. So this is another car, right? So we've been looking at cars. But in AP Physics 1, which is algebra based, we like to start out by looking at objects as if they're a single point or a single particle. So I'll be drawing it in a second, but to just stimulate some thinking, imagine this car right over here, imagine if that car was all concentrated into one single point. So all of that car's mass was stored in this point. If we think about it like that, that's exactly how we like to think about it at the beginning of Physics 1. We pretend like each object's mass is all concentrated into one single point. And you might be asking, why would we do this? That's kind of inaccurate, right? If we have a car, it's important to understand the car's shape and size has an effect on its motion. But a caveat to that is, although that is true, in Physics 1 that's algebra based, if we have to keep track of, that size and the shape of this car, that kind of requires a lot of advanced math, and that kind of bleeds into a little bit of calculus. So to really understand this car's shape and understand how each individual aspect of this car has an effect on its motion, that would be really computationally intensive, and it's not really the goal of Physics 1. The goal of Physics 1 is to help you understand relationships between objects, relationships between motion diagrams and projectile motion and things like that. And if we spend too much time focusing on the shape of an object, we really miss the mark, and it's really hard to understand relationships, and we'll be more focused on calculations. So I want to help you understand what a particle model is by drawing car B's motion. So this is car B's motion, this whole car B's motion diagram. I want to help you draw that in particle model form. So to do that, all we do is wherever there's a car, we will just draw a point. There's a point here, a point here, a point here, a point here, point here, and a point here. Okay? So each of these, so this, let me just label it actually. This is still car B's motion, but this is particle model form where we don't care about the car's shape. We only care about the car's mass. And we basically, let's say this car's mass, if you don't know what mass is, we'll be talking about that later, but let's say we'll give this a car mass of 15. For this whole entire car, the mass is 15. But if we talk about particle model, we concentrate all that mass into one single point. This has no shape, no size. This is one single point, literally one single point. It's the smallest of the small, one single point, and we're going to concentrate all of that mass into one single point. That's obviously not possible. That kind of would lead to a black hole in real life. But remember, this is just for you to understand, for beginners to understand the basics, really understand the core. We want to understand the core of something before we talk about, the real life aspects of it. So using the particle model helps simplify things, right? So we like to simplify things in physics in order for it to be easier to understand. All right, so this is going to be a particle model. And just like it was before, this is frame 1, this is frame 2, this is frame number 3, this is frame number 4, frame number 5, and frame number 6. But we're going to want to get used to, instead of naming a motion diagram by their frame number, we're going to want to start naming it by, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, and 6 seconds. So we're adding a actual numerical amount of time to each frame. So, because if we just talk about it as frames, we have no idea what that interval of time is. But now if we give it actual seconds, this is 1 second, 2 second, 3 second, 4 second, 5 second, 6 second. Now we know that the interval between each frame is 1 second. And we'll be talking about, when we start to talk about straight line motion, how we can use motion diagrams to help us determine the actual the number of speed this car is traveling at, the actual number. Like if you've ever been in a car, you're traveling 60 miles per hour, 20 miles per hour. If we give an actual time value to each frame, we can start to calculate those types of things, and we'll be talking about that later in the course. So this is really what a motion diagram is, and this is the type of motion diagrams. This is the motion diagrams that we will be seeing. So just to make you understand, this is the motion diagrams we will see. This is the ones you're going to be dealing with primarily, all right? So just keep that in mind. So the last thing I want to do is give you just one last question. I know this video is pretty long, but I'm hoping you got a lot out of it. So the last thing we're going to do is give you a particle model question. It's pretty simple, okay? Just a last activity before you move on to the next video. So let's say we have frames at, let me just draw let's say we have a particle, right? And it's going to the ground. So we're going to draw 3 different particles and 3 different paths. So let's say this is the first particle, and this is the path it takes to go to the ground. So let's just mark the ground really quickly. Let's say this is the ground over here, all right? Now let's look at a second particle. So they all start over here. This one is going like this. So that is a second particle. Now let's look at the third particle. It's the last and third particle. This is the third particle. So I want to ask you the question. Let me first actually label these frames. 1 second, 2 second, 3 second, 4 second. So this is kind of a vertical motion diagram. You probably it's basically the same thing. If you tilt your head, you can kind of see it's a horizontal one, but this is vertical motion. We're talking about an object falling down to the floor. And my question is, which of these particles is traveling at a constant speed? Constant speed. Pause the video, see if you can figure it out, and then come back. So I'm assuming you've paused it. So if we look at constant speed, we have to look at the distance between each frame. So this is a distance between 1 second and 2 second, distance between 2 second and 3 second, and distance between 3 seconds and 4 seconds for the first particle. And we can see that each of these are the same length. So if this is length x, this is also length x, and this is also length x. These are all the same. So that's for particle 1. If you look at particle 2, this distance is smaller than this distance, which is smaller than this distance, which is smaller than this distance, right? So this distance is getting bigger and bigger. So if we remember, when the distance is getting larger and larger, this particle is speeding up, right? And then the last frame is this distance starts out big, then it gets smaller, then smaller, then smaller. And if we remember that, this particle is slowing down. So I won't be really explaining it that much in depth anymore. I expect now that you understand that when an object is having a smaller and smaller distance between each frame, it's slowing down, larger and larger, it's speeding up. And now if we come back to the question I was asking, which one is traveling at a constant speed, we can see that it is indeed this one, as it has equal distance between each second at a constant speed. So it would be this particle.